Welcome to another one of my SAT mathematics videos. In this video we're going to look at algebra. There are some basic things that I have taken the liberty of not including in this video, but they should not obstruct or ruin your SAT preparation in any way, or they should not inhibit your ability to follow what I'm saying in any way. If they do, please do leave a comment so I can clarify that. And that being said, let's start. The first thing I want to look at quickly is how to multiply two binomial expressions. It's something that the SAT expects you to know. So what you essentially do is you multiply each term in the first binomial with each term in the second binomial. So you multiply this with this and this, and you multiply this with this and this, and add all of them together. That's what you're doing in essence. In case you can't recollect that, there is a nifty way to remember it. It's called the FOIL method. It involves multiplying the first in both of the binomials, so 10x into 70x, 70x squared. O stands for outer, 10x into 5, 50x. I stands for inner, 3 into 7x, 21x. And L stands for last, 3 into 5, 15. You add all of these together, 70x squared. These both have the exponent of 1. So you can add them together, 50x plus 21x, 71x, and this is just 15, and that is the solution. Use it by multiplying a plus b into a plus b, or a minus b into a minus b, or multiplying these together. You will get the value on the right hand side, but these are identities you really need to memorize. You need to know a plus b the whole square is a square plus b square plus 2ab. A minus b the whole square is a square plus b square minus 2ab, and a plus b into a minus b is a square minus b squared, right? So one way in which they can apply these questions is they might ask you to find 39 square. They might ask you to find 39 square, right? And if you do not want to multiply, one way you can use this is take a as 40 and b as 1. 40 minus 1 is 39. That is equal to 40 square plus 1 square minus 2 into 40 into 1, right? So 40 square is 1600. That's easy to do. Plus 1, so 1601 minus 80, right? So that is 1521. And if we check over here, 39 square is 1521, which is what we had originally expected. Another way they might use these formulae is these identities is they might give you a word problem. They might say the difference between two square numbers is 21. The square of two numbers is 21. They may say the sum of these two numbers is 5, and they may ask you to find the difference between the two numbers. So the first step is always to take these two numbers as x and y. So we know that x square minus y square is 25, and the sum of these two numbers, x plus y, is 5, right? We have the identity that x square minus y square is equal to x plus y into x minus y. X minus y is nothing but the difference between the two numbers. Therefore, if we divide 25 divided by 5, you would get the difference, which is also 5, and therefore this question is solved. Now the question might go one up, and they might ask you to identify these two numbers. At this point, what you're trying to do is you will look at which two sets of numbers follow all this. So we'd look at we'd see which two numbers, when you add they have a sum of 5, which two numbers have a difference of 5, and for which two numbers is the difference between these squares 25, right? At this point you would have multiple choice options, so all you would have to do is check which option corresponds to the facts given, and at that point there is no way you'd get it as a fill-in answer, and there would be options. Out of the top of my head, if you're interested, the two numbers in this case could be 5 and 0. 5 square minus 0 square is 25. 5 plus 0 is 5. 5 minus 0 is also 5, and therefore the two numbers are 5 and 0. Another thing you need to look at is solving linear equations with one variable. That's what linear equations with one variable, right? So you might have a simple expression like this. What you're supposed to do is group all the variable terms together, and group the numbers together, and group the x's together, right? Or a's or b's or whatever that is. So we'd add these together, 32.4x. We take the 162 to the other side, so we could group them together. That is 486. Now at this point we want to isolate the x, so we would divide both sides by 32.4. dividing both sides by 32.4, we would get x equal to 15. Just a quick note, whatever you do, once you reach this stage where you're moving things, don't think of them as moving things, rather think of them as applying the same operation to both sides. To get rid of this 162, you're adding 162 to this side, so it becomes 0. But because you're doing it to the left hand side, you also need to do it to the right hand side, so we are adding 162 here. Here we're dividing by 32.4 to isolate the x, so we have to apply the same operation here, and therefore we divided by 32.4 to get x equal to 15. If you think like the idea of making it sound like the 32.4 crosses to the denominator makes it easier for you to understand, that works too great. Or if you think taking it to the other side makes more sense to you, use that. But ideally what we're doing is just applying the same operation to both sides to get x is equal to 15, right? Another thing you need to know how to solve is simultaneous equations, right? So simultaneous equations involve two variables and two equations like this, and they have the same generic process of solving them. I hope that you have been pausing the video as the questions have popped up on your screen, so you can solve them and then look at how I've solved them in case you didn't know it. And if you have seen things that you do know already, like simultaneous equations, solving normal linear equations, these are pretty easy things, so I am pretty confident that many of you do know how to do this. I hope that you're just skipping ahead after solving each of these questions. Anyway, with that being said, so the first step of doing this is, what you need to do is try to make the absolute value of the coefficient equal for any one variable, right? So either we need to make the coefficient before x equal for both the equations, or the coefficient before y equal for both these variables. Now for coefficient before y equal, right? So as in, if this is 2, we need to also make this 2, and if this is 4 and this is 3, we need to make this and this another number such that they're equal, right? Now one way to do it is 4x plus 2y is equal to 8. One way to get this is get another 2 before this. The sign does not matter for this first step, we just want to get a 2 anyhow, so we can multiply everything here throughout by 2. Or the second thing is, we can get the number before the coefficient of x to be equal on both sides. So we look at the LCM. The LCM of both these numbers is 12. So we multiply the first expression by 3, so this becomes 12, and multiply this by 4, so it becomes 12. Remember, we multiplied the whole expression. So either way, what the second way will achieve is it will make both of this 12, and the first way is making both of this 2. Both work. You can choose either. So another note for this is, you multiply this number you're putting throughout. So 2 into 3 6x minus 2y equal to 2. So it multiplies throughout the expression over here. Following that, you should have come to this. After multiplying it throughout. Then the idea is that you get rid of one of the variables. Now here we can see, if we add both of these expressions together, the positive 2y will cancel out with the negative 2y. So we add both of these expressions equal if the signs are opposite. In this case, you'll get 10x plus 0y is equal to 10. In the second case, the signs were same, both the x expressions were positive. So in order to make it 0x, you would need to subtract the second expression from the first. So it will become 12x minus 12x plus 6y minus 4y, that becomes 10y, equal to 24 minus 4, which is equal to 20. Following that, you can solve for x and solve for y. You get x equal to 1 or y is equal to 2, depending on which method you took. Finally, you substitute this in any one of these two initial equations. So in this case, I'm substituting the fact that we got x equal to 1 into this. So we get 4 plus 2y is equal to 8. Therefore, we get 2y is equal to 4, which is y is equal to 2. That is correct. And in the second 2, we could have substituted in the first. Let's substitute in the second for this. So 3x minus 2 is equal to 1. We take 2 to the other side. We get x is equal to 1. And we see that it works. A quick way to verify whether your answers are correct is, in this case, we got the system where x is equal to the solutions are x is equal to 1, y is equal to 2. Quickly check back into your quickly substitute into your original equations and see whether you get the same result. 4 into 1 is 4, plus 2 into 2 is 4, 4 plus 4 is 8, it checks out. 3 into 1 is 3, minus 2 is 1, so it also checks out. So over here we cannot get 2x divided by z, because then there is no way of isolating the z from the x. We see that the z is always tied to the z is either tied to x in the product 5x by z 5xz, or it is with the tied up with the x in the form of 2x divided by z. So it appears that there is no way to get rid of it. So in this case, what we are going to do is multiply out the brackets first. So that would become 5xz plus 2zy is equal to 2x. Right? The second step would be move everything with x to one side, because that's what we want to make the subject. So we keep 2zy here and we move 5zx to the other side. You could have also moved 2x to this side and move minus 2zy to the other side, making it minus 2zy. Then in order to isolate this x, we need to take it common. So we would end up with this. Finally, to isolate x completely, we would just divide both sides with the expression 2 minus 5z, and we would end up with this. And that is how you would make x the subject. A very common form of asking the question is for reciprocal functions. They generally have a form such as this. They might ask you to find the function in. They might ask you to find it in terms of x. So make x the subject. So what you're gonna do first is you're gonna take the denominator to the other side in this kind of question. Then you're finally gonna multiply it out as we did in the previous question. You're gonna take all of the x to one side as we did in the previous question. This is supposed to be an equal to, my bad. Then we're gonna take x common, and then we're just gonna move that to the denominator, and the question is solved. There are a number of typos within these presentations. I do apologize for that. With that, in the next video, we're gonna look at quadratic, cubic, and exponential equations. And with that, thank you guys. Do have a great day.